Then in today we will try to solve the second order linear differential equation. The form of the second order linear differential equation, it will be this one, which it has the second derivative. The coefficient inside this equation, it can be constant and it can be function or variable. If the coefficient is constant, we will rename it second order linear differential equation with constant coefficient. And if the coefficient are function, we will rename it second order linear differential equation with variable coefficient. The right hand side, it can be 0. At that case, we will rename it homogeneous differential equation. And if the right side not 0, number or variable even, we will rename the equation non-homogeneous differential equation. Then now we will try to solve the second order linear differential equation with constant coefficients. That means those constant A and B and C, they are constant, they are just numbers. And our solution depends about the right hand side. For the right hand side, we have two cases. If the right hand side if equals to 0, that means we have homogeneous equation. At that time, the solution of the differential equation, the general solution, equal YCF, where the letter C and F refer to complementary function solution. And in case of the right hand side not equal to 0, that means this is not homogeneous equation, non-homogeneous equation, and for that case, the general solution equals YCF plus YPI, where PI refer to particular solution. Now I will try to solve this second order differential equation. We consider it second ordered where we have the second derivative. And this second order differential equation with constant coefficient, where the coefficient here just 5 and 4, just numbers. And where the right hand side equals to 0, that means this is homogeneous equation. And because it's homogeneous equation, that means the general solution of that equation equal YCF. Then now I will try to find the value of this YCF. To find the general solution of this equation, first I should find the auxiliary equation. The auxiliary equation here, it is m squared plus 5m plus 4. It is quadratic equation. I will try now to solve this equation by factorization. Then this equation, it will give me two roots, m plus 4 and m plus 1. Accordingly, m it will become negative 4 and m here equals to negative 1. By the help of those roots now, I can formulate the YCF. YCF equals C1e plus C2e. The power of the first exponential, it will be the first root, which is negative 4 multiplied by t. And the power of the second exponential, it will be the second root, which is negative 1 multiplied by t. Here is the answer, and this is the solution, and you can consider it as the general solution. Again, in example 2, I will try to solve this differential equation. First, it is second order because of what? I have the second derivative. Second, the coefficient here, 4 and 4 just constant. Then here I have also constant coefficient. Third, the right hand side, which is equal to 0, that means this is homogeneous equation. Regard that, the general solution of this equation, it will be the complementary function itself. To solve this equation at beginning, I will try to find the auxiliary equation, which is m squared plus 4m plus 4 equal to 0. Now I will try to factorize this equation to find the roots, which is m plus 2 and m plus 2. Accordingly, the roots, which will become m equal to negative 2 and m equal to negative 2. The special about those roots here, they are same. Now from those roots, I'll try to form the solution. Then YCF, the complementary function solution, equals C1e plus C2e. The first root here negative 2, then I will type negative 2t, and the second root also same negative 2t. Hence the roots, they are same, their value is same, then I will multiply the second term by t. Then now this is the general solution. Now in example 3, I will try to solve this homogeneous differential equation, which it has this auxiliary equation. Now I will try to factorize this equation by the calculator. It will give me this answer: 2 plus and minus root 5 multiplied by I. The special about this root, I have real part, I will rename it alpha, and I have imaginary part, which I will rename it beta. The YCF for this special case, it is e to the power alpha t multiplied by C1 cosine alpha t plus C2 sine beta t. Then regard that I'm going to remove this alpha, and instead of alpha I will put the value of alpha, which is just 2. By the same way I will remove beta and I will put root 5, and I will remove beta again and I will put root 5, and then this it will be the complementary solution or the general solution. Then the conclusion: if the roots of the auxiliary equation they are different, suppose, at that time the complementary solution it will become C1 multiplied by exponential and C2 multiplied by exponential. The powers of those exponentials will be 1 time 2t and the second time 3t. The second case, if the roots of the auxiliary equation they are equal to each other, then at that time the complementary solution it will become C1 e to the power 3t, C2 e to the power 3t, but multiplied by t. The third case, if the root itself it has real part and imaginary part, suppose, in this case we will rename the real part as alpha and the imaginary part as beta. And for this special case, the YCF it will take this special form. And all you have to do now just to substitute inside that form about the value of alpha and beta. Now you can solve all of those homogeneous differential equation and share your solution with me. Thank you.